Find the value of secant square x minus 1 from the given equation. First, let us simplify the determinant of the 2 by 2 matrix given in the right-hand side of the equation. It implies that determinant for elements u1, -1, and u equals the square of u minus -1 equals the sum of the square of u and 1. Substitute this value in the given equation. It implies that for times the square of sine x equals 3. After simplification, divide the equation by 4 and we have that the square of sine x equals 3 divided by 4. Take the square root of the equation. Hence, sine x equals half of the square root of 3. Take the sine inverse of the equation, and we have that x equals the sine inverse of half of square root of 3, which equals to 60 degrees. Hence, the required value of the expression secant square x minus 1 equals the reciprocal of cosine square x minus 1, which equals 3. After substitution and simplification of values as shown on the screen. Therefore, secant square x minus 1 equals to 3.
What is y given that the product of matrices P and Q equals matrix R? Let us multiply the two given matrices, PQ. To perform multiplication of two matrices, we should make sure that the number of columns in the first matrix is equal to the number of rows in the second matrix. The arrows indicate that the multiplication is row by column. Each row of the first matrix multiply each of the column of the second matrix, consecutively with internal additions. Thus, let us perform the required multiplication. 3 multiply to 1 add up to 4 multiply to -2. This is for the first element of the new matrix. For the second element of the first row, we have that 3 multiply to 3 add up to 4 multiply to 4. For the first element of the second row, we have that 2 multiply to 1 add up to y multiply to -2. And finally, for the second element of the second row, we have that 2 multiply to 3 add up to y multiply to 4. Our initial simplification equals 3 minus 8 and 9 add to 16 for first row. For the second row, we have 2 minus 2 times y and 6 add to 4 times y. Simplify further. Now that we have gotten the value of the product of matrices P, Q, equate the result to R, which the equation is already given as shown on the screen, and compare elements of the two matrices, and we have that For 2 minus 2 times y equals -8 and for the sum of 6 and 4 times y equals 26. Any of the two equations can give us the desired value of y. Thus, we use the first equation. That is, 2 minus 2 times y equals -8. Rearrange terms and combine like terms. Thus, 2 times y equals the sum of 2 and 8, which is equals to 10. Divide the equation by 2 and we have that. Y equals 10 divided by 2 equals 5. Therefore, y equals to 5. The correct option is D.
Required to find the value of x in a mixed matrix and logarithmic equation. Step 1 is to find the determinant of the given 2 by 2 matrix. That is, the first element multiplied to the fourth element minus the second element multiplied to the third element. We call the expression obtained equation Q. Convert the second multiplier expression to base 10. Log 3 times x minus 2 to base 5, divided by 2 equals to log 3 times x minus 2 all divided by log 5 divided by 2. We call this equation y. Substitute equation q and equation y into the original equation. We obtained equation 3 as shown on the screen. But the difference of the square of log 5 and the square of log 2 equals the product of their difference and their sum. By the law of logarithm, log 5 divided by 2 equals log 5 minus log 2. It means that the product of the difference of log 5 and log 2 and their sum multiply by log 3 times x minus 2 all divided by the difference of log 5 and log 2 equals to 1. Equal fractional expression cancel out. Simplify and we have equation 4 as shown on the screen. But the sum of log 5 and log 2 equals log 10, which is equals to 1. Substitute this in equation 4 and we have that. Thus, the product of 1 and log 3 times x minus 2 equals to 1. Take exponent of both sides of the equation. We have that 3 times x minus 2 equals 10. Simplify by solving for x. We have that 3 times x equals to 12. Divide the equation by 3 to give that. X equals to 4. Hence, x equals to 4. Therefore, the correct option is C.
Required to find the value of x in a given matrix equation. From the left-hand side of the equation, we need to find the determinant of the 3 by 3 matrix. To achieve this fit, we have to find the cofactors of the elements of the first row. Any row can be used, but we are using the first row. Cross the first row and the first column as shown on the screen. We obtained the product of the first element of the given matrix and a minor matrix. Find the determinant of the minor matrix and multiply it by the first element of the given matrix. Repeat the process for the remaining 2 elements of the given matrix and obey sign convention. Positive, negative, positive. If did not understand this process, I advise you to register for matrix class in our website. To find the determinant of 2 by 2 matrix, multiply the second element by the third element and subtract the result from the product of the first element and the fourth element as shown on the screen. We have in the bracket x minus 3 multiply another bracket consisting the sum of 2 times 6 minus x and 4 times 2 minus negative 4 multiply a bracket consisting the difference between the product of 5 times 6 minus x and 2 times 2 sum to the product of 3 and the difference between negative 4 times 5 and 2 times 2. Simplify and equate to negative 24. Expand brackets, simplify, and we have that we have the result shown on the screen. Combine like terms and simplify further, and we have that the product of negative 2 and the square of x plus 6 times x minus 28 equals negative 24. Thus, the product of negative 2 and the square of x plus 6 times x minus 4 equals 0. Factorize. This implies that the product of negative 2 and the square of x plus 2, x plus 4, x minus 4 equals 0. Bring out common factor from each group, simplify, and we have the product of x minus 1 and the sum of negative 2 times x and 4 equal to 0. This implies that either x minus 1 equals 0 or the sum of negative 2 times x and 4 equals 0. Thus, solve for x in the equations and we have that x equals 1 or x equals 2. The only option with these values is D. Therefore, the correct option is D.